At prime factorization using factor trees. In this video, we will explore how to break down numbers using factor trees to find their prime factors. Along the way, we're going to learn to identify the difference between prime and composite numbers, build factor trees by splitting numbers into factor pairs, continue breaking down numbers until all the branches end in prime numbers, and use prime factorization to better understand a number's building blocks. So let's see how every number is made up of smaller, simpler parts and how factor trees help us uncover them. So let's start with the number 12. So to factor 12, I need to think, what two numbers can I multiply to get 12? Well, let's see. What about 3 and 4? So 3 and 4, the product of 3 and 4 is 12. Let's start with the 3. When I notice the number 3, 3 is what we call a prime number. In other words, it has exactly two factors, one in itself. So when you find a prime number, we're going to circle it. Now let's look at the number 4. 4 is a composite number, which means it has more than two factors. It has one in itself, but it also has two other factors, 2 multiplied by 2. Now 2 is prime because 2 only has one in itself as a factor, so we circle the 2's. And that's the end of my factor tree. So we can say that the prime factorization of 12 is 2 multiplied by 2 multiplied by 3. But let's look at another example with 12. What if I didn't start out with 3 and 4? Let's say I multiplied 6 and 2, because 6 multiplied by 2 is also 12. Let's see what happens. I notice that 6 is composite. It has more than two factors. But 2 is prime because it has exactly two factors, one in itself. So I circle the 2. Now with my 6, I can multiply the number 2 and 3 to get 6. We know that 2 is prime, and we also know that 3 is prime. So notice that the prime factorization is the same whether I start with 3 and 4 or 6 and 2. They're just written in different orders, but the order doesn't matter. So the prime factorization of 12 is 2 multiplied by 2 multiplied by 3. When I write the prime factorization, I like to write it from the smallest number to the largest number. Now let's factor 18. Again, we have different choices, but we know it doesn't matter which two numbers we start with, we'll still end up with the same prime factorization. So I'm going to use the numbers 9 and 2. So the product of 9 and 2 is 18. I know that 2 is prime, so I'm circling prime. But 9 is composite. So I think, what two numbers can I multiply to get 9? And 3 multiplied by 3. I know that 3 is prime, so I circle my 3's. And that's the end of my factor tree. So the prime factorization of 18 is 2 multiplied by 3 multiplied by 3. Now let's look at 36. So for 36, again, I have lots of options, but I'm going to use 6 multiplied by 6. Both of those numbers are composite, so let's start with the first 6. So for the first 6, I could say 3 multiplied by 2, and 3 is prime, and so is 2. And for the second 6, 2 multiplied by 3, again, both prime. So the prime factorization of 36 is 2 multiplied by 2 multiplied by 3 multiplied by 3. So remember that every whole number can be broken down into a unique set of prime factors using a factor tree. And when we use factor trees, we start with a number and then split it into factor pairs. Then we broke down each composite number until we reached the prime numbers only. And remember, we circled those prime numbers. We learned that prime factorization shows the building blocks of any number, and that we saw that the order of the branching doesn't matter. In other words, it didn't matter which two numbers we started with. The prime factors always stay the same. So math isn't just about answers. It's about discovering patterns and structure within the numbers. Thank you so much for watching. And if you liked the video, click that like, leave a comment, or better yet, subscribe. I'd love that. Again, thank you so much.